For the Shadow of Doubt lab, salts A, B, C, and D will be on the buffet table in clearly labeled jars. Each has a corresponding pipette. Notice color coding orange with orange. You want to avoid cross-contamination at all costs. Each lab station has a test tube filled with purple permanganate solution. The buffet table provides sulfuric acid and heptane. These need to be shared, so please don't monopolize a bottle for your table. One of the skills you want to acquire today is the ability to measure 1 milliliter accurately using one of these pipettes. The pipette has lines on it. This line near the top says 2 ml, 2 milliliters. This line in the middle says 1. That's 1 milliliter. To get 1 milliliter of liquid in your pipette, there are two strategies. Strategy number 1 is to try to pull up liquid until it gets right on the line there, and that requires significant skill. That's great. Another strategy is to squeeze down the bulb all the way, slowly pull up liquid till you're past the 1, and then squeeze out the liquid until you reach the 1. There's 1 milliliter in the pipette. If I let go now, this is still 1 milliliter because it filled the pipette from the bottom to here. So I have some air, but the liquid is still 1 milliliter. To deliver to a test tube, I squeeze the bulb slowly, and all the material in the pipette should be transferred so that my pipette is empty and my test tube has a milliliter in it. Later on in the lab, you'll use heptane to do what's called an organic extraction. Heptane is a nonpolar solvent. Here I have a solution of copper sulfate, and I'll demonstrate the concept of the extraction. I will add a milliliter of the heptane to the tube. When I do that, you can see that the heptane, being nonpolar, does not mix with the water layer. The heptane is on top of the water. It's less dense. Here I'm vortexing. I need a vigorous vortex to have an effective extraction. Here's what I observe after my attempted extraction. Here you can see the bottom layer, the aqueous layer, is blue. The top layer is colorless, meaning I did not extract any of the colored ions into the nonpolar solution, which should make sense because ions love water. Here's a second solution that does have nonpolar colored molecules, which preferred the nonpolar layer rather than the aqueous layer. Here's a model for what happens in an extraction on the molecular level. You'll get two layers. Top layer will be the nonpolar solvent heptane. Bottom layer will be the aqueous water solvent. You can see that ions make friends with the water molecules. The delta plus and delta minus attract the ions, so the ions will accumulate in the water layer. But something nonpolar like bromine, Br2, has no plus or minus, so it'll tend to accumulate in the top layer. There will be an equilibrium between the two layers, so you shouldn't expect 100% of the nonpolar to end up here, but maybe 90-10 or 80-20. This can give you valuable information. For example, here I have two tubes. I have the same color, but in one tube, the one here, this color must be due to polar substances or ions. Whereas in the other tube, this color must be due to nonpolar substances. So this can give you valuable evidence. At the very end of the lab, you'll need to use the waste beaker. Dump your test tube contents into the waste beaker.